Hello, good evening. Today we're going to be talking about virtual machines using Codex. So let's just jump right into it. Let me ask, do we have any virtual machine software in our computer? Like Kennel. This is an M5. So I'm trying to okay. Let's just kind of do an inquiry. Typically, if I was running like Codex, you can run your Camo and you can actually manage the whole thing. But I think I do have Camo and UTM. Yes. Okay. So virtual machine, I found that Codex is really good at helping me create my custom virtual machines. To the point where I kind of learned more concepts about virtual machines that I didn't know before. And so I'm using as to learn. For example, if we build a custom Fedora environment, I want to build an image that is specifically to what I want, and I want to freeze it so it has a persistent state that I can always come back to it. That's hot. Then I kind of learn how to fracture that into like memory, so that way at any point I can always go back and forth. So virtual machines are very powerful because if there was to be a compromise in any service, all it has to do is stop, go back, and then send it to an agent where it can figure out what happened, patch it on the fly, resume, and go back live. That's kind of the concept. A lot of the services that are been kind of like Docker and virtual machines. I like virtual machines just because what I've been using for a very long time. Not that I know a lot of advanced stuff, but with Codex I've been able to kind of experiment with very advanced networking. So that's be something that I can do in the next video. So let's say, can you spawn it for me? I want to write a basic hello world program. Now at this point I'm not even asking, hey, we're gonna go straight to the bootloader. And I wonder, can it do it? x86-64? No, I think. Let me see. You can only do ARM. Again, I'm also learning about the capabilities of the software. Okay. I do want native. Custom folder. And the cool thing about Codex, you can actually steer it. Like for example, if you do see it kind of going in a direction that you don't want, you can kind of steer it, or you can just kind of, if you change your mind, you can delete it and say no, I like the other one better. So we're just gonna ignore that one. You can actually edit it while this is happening. You can actually see also what it's working on. Okay, so right now I guess it's just gonna generate the machine code. Yeah. And the cool thing is that you might not necessarily understand everything, but you can actually see how I use Python to write these instructions and then kind of build the image that it will be loaded to Camo. And then you can see the kind of the make file to see how it's compiling this. All this information is very important to save it if you're training. Okay. Okay, so let's actually try it for ourselves, because that's something that you always want to do, is you want to try something for yourself, because that's what makes it fun. So let's go ahead and capture the screen, window capture, and we're going to capture not that, hostcito terminal. There we go. Getting the hang of OBS here. Hang in there. Okay. Hello from bare metal. Arch. So it actually literally wrote an executable to the architecture. So and so then you can say, well, Cortex A72, what is that? So let's actually close this out. I don't even know how to terminate it. I'll just tell it to terminate it. Okay, then. Also, tell me more about this architecture. Okay. This is a cool thing because you're kind of like learning, right? Using tools. Let me see. Use the way this back there. Of course, you're just gonna emulate all kinds of architecture. Okay, so let's go ahead and open a terminal. Yep, so send a signal to terminate it. Okay, let's take it from the screen here. Okay, that's pretty cool. Because you're kind of stepping outside of just generating chat, just like a chatbot, but now you're seeing that you actually can write real code on real software, like an emulator's a real piece of software that emulates the architecture of a machine. Okay, so we can actually save this and create another project. I mean, because you don't see, when you kind of work on something, you kind of leave it as is, unless it's related to the subject. So if I start talking about, hey, my rent went up by $500 and this and this and that, you are poisoning your entire project that you just worked on, just because you're treating it as a chatbot. Okay, so let's take it a little further here. Is it possible to build our own architecture? If so, what is the best data set? And probably it's the wrong way of reframing this. Architecture. And then Apache. Just thinking out there. I already know the answer. I know you can build your own architecture and patch the code. The code is open source. So no, that's not what I was asking, but that's fine. Now, so within Camera itself, it's already compiled. You'll have to go to the source file and kind of make the changes for the architecture that you're trying to run. Yes, okay. So this is just kind of like for those who kind of like want to start building their own virtual machines, essentially. Got it. Yeah, you can fork. That's cool. Again, I have to kind of keep. You can fork conversations and go a different path. But yeah, what else can we do here? So very easy. Let's actually go straight forward, because we're already we're already pretty deep into this. 8 minutes in, right? So might as well just finish the job real quickly. So I show you exactly why I came here. Let's pick a version of Fedora that is very minimal. I think it's called is it? Like a net installer. Most basic base with OpenSSH. Okay. Don't expose credentials. Save them locally and never give them out, but always know how to sudo yourself for any future prompt. Make it in memory. Have a local use version control to be able to go back and look without a problem. Okay. I guess open EMT and also verbose in terminal that I have open when we launch it. Showing audience on YouTube. Let's install it automatically. Get the ISO and do your job. I've done this quite a few times that I feel confident that it will do a good job. So what we're doing here right now, let me hide this. We're just gonna download an ISO. It's like a net installer, and then have it automate the installation completely. But hopefully we can actually watch it in real time. Can we watch it in real time, every step, with your reasoning, so my audience can see it? So here we can steer it quickly. We don't want to break anything that's in the process. Okay, I might have to add, I don't want to get too ahead, so let's go micro screen capture, wind application capture. I have to learn how to use it. I already had Windows there before. Let me see what it's doing. It hasn't created the machine yet, so I have nothing to show you. Okay, that's just the terminal from earlier. Maybe it will use this terminal. We shall find out. We do want UTM. Hopefully it uses it. And it will be in Windows Capture, and it will be Codex in the background. And then we have to say that goes into the bottom. Cool. Okay, it's gonna take 3.4. We're skipping that. Yeah, 1.2 gigabytes. Wish I did have multiple monitors, makes it easier. So cool. So what's happening right now, we actually instructed it to get an ISO file. And so we kind of, when you come out of your bubble, you start realizing, okay, so you can create ISO files, you can build images, can run virtual machine, can set up networking, set up services, you got your Apache, web server, MySQL. So you start building this modular design out of virtual machines, and then you have the physical layer, which you have to do your physical switches and your wiring. And you can have another one that does the firewall. When you start realizing you can have this kind of build an entire cluster for you, depending what application you're working with. So you see the real physical impact of using AI. Hey, we got a couple, 2-3 guys. We used to have, let's say, 10 engineers, and now we got 3 guys. One is professional, and the other 2 are very passionate and very creative. And you have these people building like massive projects, because you're all collaborating together. This is the kind of thing that we can do. So like custom Linux distributions, like pick a flavor, pick a set of packages, pick an application or a tool or something you're trying to do. Okay, so we're gonna start allowing, and we can do it. So we're gonna allow it to use our UMT. Okay, so that's actually, it's going to start picking by itself. It should pick others, or it's just going to pick Linux. Okay. I didn't give it any context, but it should be aware of my memory availability. It should click browse, and it should locate it. So it should know the location, or just type in the path. That's the best thing you can do. So what I'm actually doing now, I'm actually visually seeing what it's doing. Hopefully it doesn't pick my pictures. My sexy pictures. Probably put it in. What did you put in? We'll probably put it in the user profile, and then No, buddy. You probably want to move it to where it says downloads. Now, another thing that would be cool with Codex, and we can say OpenAI, that we can kind of guide it with our voice, but it needs to. We need better latency. You know, it's just not there. Um, would it be under projects? Here we go. I found it when I searched for it. So I'm actually supervising. So I'm just kind of like a manager watching this AI system do its thing, which is pretty cool because you actually can record this entire session and then upload a video of how to do it and actually use your real voice, which is exactly what I'm going to do. So I'm showing you my OBS. I'm in OBS doing all this. Any kind of tool you have, you can teach people how to use them because the AI can navigate and you're here to supervise it, right? So that's pretty cool. There's like complicated, like multiple steps, and you can kind of learn. I should click the play button now. Now, as a human being, I know what it's going to do, or this is what I would do. Flip that, come on. Now, did it fail? Okay, no. Let me see if you guys have access to. I am screen capture. That is my mistake. There you go. Yeah, Fedora. There we go. I have to kind of teach it probably. How to understand that I'm using OBS. I think that will be my next step. Teach it to know that I'm on OBS. Can it add the sources and everything for me as it goes on the back end without being interrupting? That would be pretty cool. If I had another monitor, I could see what it's doing in real time. Oh, I can actually steer it right now. Whoa, look at that beautiful thing. If I had another monitor, that would be a cool thing if it could control the environment without actually touching my physical mouse. What did you do, buddy? Do you need permission? So this is some of the stuff that I'm coming across. Okay, go ahead, have permission. Now, because I kind of see where it's going, let's go give it full access. Why not? I only use this computer specifically for research, so like there's not much that can be exposed. So we just kind of broke our own rule just to see if we can move along. Okay, it says it's going to touch the controller, so I'll go ahead and touch it. So remember, the goal was, see, it's doing exactly what I expected. It probably to restart just to kind of get more of a visual. It's because it's going to take screenshots. We need a model. No, you don't have to modify anything. We need a model that can quickly grab the screenshot and translate them well. No! Let me help it. You guys saw what it did. So that kind of stuff happens. So my idea was it had to take the ISO and build an automatic like a script to auto install it. So let's actually, but then it kind of defeats the purpose of the visual. I wanted to see if it can visually do it, and that way you kind of explore and learn how like tools work and how an AI system do certain configurations. Okay, so the cool thing is I'm in control of this. Oh, did it pause it? Okay, let's just not touch it. We can automate it. I think it's called Anaconda script, or maybe that was the name back in the days with Fedora. Or, but I know I can't do it because I already did it on another system. I guess this one I went the visual route. So let me see what you guys are saying. I mean, at this point, it doesn't have to navigate the GUI. In fact, in the background, if I was the AI system, I would just create the script and all those parameters because it's easier than navigating this visually. And at some point, we should be prompted that it's done or restarting into the environment. Because it's already pretty much loaded. We're just kind of running another program. And that could be the automatic installation. I could have had the image already created. Well, the script already created, so when the image ran, it just ran the code and it just gave me the output that I wanted. But that's fine. It's just a long way. At least it kind of shows you that the AI can navigate visual elements. Okay. Okay. Now, are you using the same session? Are you injecting it through serial? What is it doing? Are you launching another virtual machine? And this is kind of very important because you kind of learn about the limitations of a model if you're not specific enough. Like, I could have been more specific saying, okay, build it in the background, show me verbos and a terminal so I can see what you're working at every step. And then when you're ready to launch it, go ahead and launch it so I can show the audience the visual. That is actually the right way of doing it. Because I failed to be specific. This thing went on giving me the visual, getting me nowhere, but then just kind of defaulting back to exactly what I was talking about, Anaconda kickstart. And I think that's just like automating kind of like configurations. So I want to step in and say, just to make sure it's aware, UTM is still there running virtually. Now, why are we binding to HTTP? I gave it full access, so this is the kind of things that happen. If you wanted to kind of supervise it, I would just do like only when unsafe. It's not really unsafe, but it shouldn't take this long. Actually, it did take a little bit long to build the whole thing before. Go ahead and stir it. It's gonna hold. It should hold that state. Most likely, will terminate it. You see, okay. When you start understanding how the model will make its next prediction. This is an extremely bad example. Okay. Okay, I stopped it. Okay. So on my end, as an engineer, I made the mistake of not being very specific with my prompt and my requirements. If I would have taken I'm sure that if you make a video following the calculator that I made, we follow the specification of the calculator, the same kind of format, and we used it for this project, it would have been more effective. It would have been more precise. This installation would have most likely been done already and deployed live, honestly. Okay. It doesn't have a terminal, right? Let me go ahead and check. This is blocking the whole thing. Again, I am learning. Yes, it doesn't need this terminal. Sorry, guys. I don't know where it went with this HTTP because it should have embedded the script in the ISO itself. I wonder if it just unpacked the entire ISO and it's doing that. It's kind of like, no, why would it unpack it? Now, I did say on a terminal, I would like to see. Let me close this terminal, for example. Could you show me? We're just going to stir it quickly. I think every time you stir it, you do introduce the potential for it to miss something, unless it kind of halts, takes it as a context, finishes its train of thought, and then continues unaffected. And now it's like a very boring process. But I think it's important to kind of learn. Like if you're trying to, for example, think of a particular skill or some sort of concept that you want to experiment with, you have to take your time to understand what your models are able to do. Okay. Okay, cool. So it did exactly what I told it to do. Okay, so it's actually showing us a visual in the terminal of everything that's happening within the environment itself. So it actually followed that very nicely. If I had, let's see what it's doing. Now the cool thing, I mean, I'm just thinking too much here, and I was slowly transition here to, you know, end this video or this live stream. But a lot of this data, like if you're overseeing different systems, different processes, like you see how long this has taken, this task. I didn't have to prompt it too many times. So this actually kind of showcases, it proves my point. You don't have to be constantly prompting Codex of these models. They're designed to work with multiple steps. You just want to ensure that there is safety in each of the steps, and then your permission again. If you kind of run this full access, then of course it can just keep going and keep going. So that's the benefit of it. Unless you introduce a mechanism to have some sort of safeguard, I would not be 100% full control all the time. Just my opinion. I did come across one time that it sort of poisoned itself, and it could have formatted my drive. So, okay. Did it terminate it by mistake? Okay. Okay. So at this point, you have burned. This is what I'm going to do. I'm going to stop it. Okay. When you stop it, it's not a really good thing. I think this is kind of like it will have to go back a little bit and read. Maybe that's the theory, but I'm just going to make it really easy. Make a automatic script to install it into the virtual disk. Make it fast, no fuss. Make user and choose default settings and open this. Should take you, check out, 2 minutes and I don't know, 48 seconds. Go. So now we're going to see if this model can work under pressure. We have wasted enough time, but it has enough context of what we want. We simply want a script. We want a solution. Go in there, grab the ISO. You know exactly in your training data how this would work. In theory, right? So let's see if it actually remembers to open the terminal. Or it's just just go right through and say, hey, I'm done. And then we just have to tell it, give me the command, spawn it so I can show the audience. That's one way that it can go. When you start being able to predict what your model will most likely do, that makes you have a really good understanding. If you don't know what the model is going to output, then you don't have an understanding of that model, and it's just going to take more time. Now, let's see. Now, you already know things that it's going to ask us. It should be very deterministic. It's not like one time you're going to boot the ISO and it's going to say, hey, happy birthday. We have a special option for you to pick. It's not going to do that. Random code is not going to show up on something that's already predefined. So it's kind of a thing that it's painful because you kind of generate once. But once you generate once, it's very rewarding. I have like 8 different ISOs that were generated, different versions with different packages. But I went through this exact pain going through, it's actually one of my worst ones. In fact, I think the second time it did much better than this entire. I burned more tokens now than I did then. And that was with 5.4. So I'm not sure, maybe something that I'm experiencing, but I believe that 5.4 was slightly better in some things. Okay, went ahead and made that. It spawned 2 terminals. I'm not sure why. It did remember. Okay, let's see. Okay, what is it doing? Okay, it failed to load something. I probably have to close that out. Just an isolated boot mechanism. We shall see. One thing I'm thinking here also, if I'm going to be using Codex to kind of show these examples, I would like for it to manage OBS. What's seen, and of course you guys won't see this, but if it can manage OBS. Quick question: anybody out there who actually has an AI agent manage their OBS? So in the workflow, it would consider OBS scene to scene, because that would be actually pretty cool. Like if you're talking to an AI system, let's say you speech to text and say, hey, open a web browser, and then it just takes the command for the web browser and then it changes the scene from the perspective of the agent, right? And then you can switch another scene um, on the attacker, on the victim's computer, for example, if you want to call it that. Just wondering if anybody's doing all that kind of stuff. I mean, I know that takes time depending on what you're trying to put out there, what kind of content. And AI is all about patience. You have to have a lot of patience. Um, they're gonna make a lot of mistakes, no matter how good the models are. Obviously, we have wasted more time tinkering with this. There you go. Let me go here. Okay, let's actually see if it already included that. Starting installer. It should have not have to go through this process. It should have already been injected. This video is actually a perfect example of not being specific enough. We should have included as in our spec file that it's a specification, meaning we don't want to be prompted for anything, no inputs. It should all be all hard coded into the code, which actually the model should be doing that right now. Okay, so it decided, hey, that was the wrong way of doing it. Let's see if it's gonna get it right now. Because I was very specific. I do not want any kind of input. I mean, it should have assumed that. Because it's going through the terminal and I'm showing an audience. So it should have inferred, well, this looks like a demonstration, so obviously it might be just an automatic, because I did say for it to choose, so it should have known that Fedora does that. Again, maybe he just has to understand. So okay, it's doing it now. Either it should know where things are laid out automatically, or it should just kind of bypass any kind of input. And it would have done it within that 2.5 to 3 minute mark, like I had wanted to do it. Because it's just a matter of downloading, and we wanted the most minimal too. We just wanted open SSH, so that way we can go back in there and then do some other work. You guys can install your packages, about 437 packages. And so this is all Codex. If we look at Codex, I mean, it's been working on this for a good while. We can check our usage, and it's actually fast, so it will use more usage for demonstration purposes. And so my hope making this videos is kind of exploring all kinds of automations, things that we can do with Codex. We just don't want to be prompting a model with all this nonsense. We actually want to build tools that we can actually put out there and say, hey, you want to build virtual machines? Like, this program builds you virtual machines. You can use this type of prompt, just kind of say what you want to do with a virtual machine and what hardware is running, and then kind of see if it builds you the custom Linux distribution. It used to be so much fun building Linux distribution by hand. It's such a lot of annoying stuff, like the ISO create generation, or like choosing your bootloader and all that stuff, can be automated. We can be more specific and more intentional with like what kind of libraries we want, especially in a system that it needs to be very deterministic. You need to know exactly what's there. Okay. Made an error here. Is that a bug? No, most likely we caused the problem. Let's see what Codex is saying. We can actually stir it so we don't actually mess it up. Yeah, that's actually save the day. So I have to step a day. I believe install, but don't give up. Get screenshot so you can save it from restarting again, but learn so it won't happen. So now what I'm saying is we're in a situation, right, that I don't have the time to go back. So please take a screenshot of this and navigate it. Now that's the problem of running it automatically. You run it automatically, most likely the model would have said, I think I messed up, or it failed halfway. Where if it's something that it requires some sort of input, something that wasn't expected, it can say, this is interesting. Let me see if I can solve the problem within this set of operations that are occurring. That way we don't lose any progress, because time was of essence. It was very important. So, but it decided to terminate it, didn't it? Let's see. Well, so the password that it shows. Wow. Interesting. More things that should be added to the console. When this project is done, it's actually a longer stream than I thought it was gonna be. 42 minutes. But check this out. When we're done with this, we can write a spec sheet with all the multiple steps and what we learn and how the Fedora image behaves. Then we can probably replicate this rather quickly. But once we got it packed to a few scripts, you can generate the whole thing on the fly with no problem. But someone has to go through the pain, and we're going through the pain right now because we're just staring at text, and our brains are being rotten. I'm not writing a single line of code. I'm simply staring it by observing behavior. So I'm kind of like the AI, and this thing is like an engineer. What it feels like. Let's go back here. So of course it has to start again. So it feels like it had to go back to the matrix. And this is just installing an image from scratch, so it's not really a big deal. But exactly what I just described is what actually should take place. It should continue installing it. Now it understands the password was wrong. That's the step. And it should also catch the input that I had to override for it to take a screenshot. It has to consider that. Now, one thing you notice is, if part of my constraint was if you made a mistake in any step of the way along anything, you should have particular function within the operation itself that you're performing, even if it's in a virtual environment, to get those packages pushed there. So let's say we're downloading 510 gigabytes worth of stuff and it fails in the creation of the image, you should be able to obtain it locally to save data. That's if we were in a scenario where it was very sensitive. But again, it goes back like the calculator. My previous live video was over-engineering a calculator. I mean, accidentally over-engineering because I'm thinking a little bit more than I should. But sometimes you do want to understand what happens when you overdo something versus when you don't do enough. I over-engineered in the first live video, the previous video, and in this one I under-engineered because I should have been very specific. I should have been very strict and disciplined in the beginning because I already done this before on another machine, so I should have used that as a perfect example. Then again, it was under 5.4. At 5.5, I'm assuming it's smarter than other benchmarks. Don't know much about the benchmark specifically, but I think it's gonna move along. And remember, it's just waiting for the process. So and because I did say OpenSSH, it should have been included in there, unless it's gonna do it with credential once it logs in by itself. It should have received some sort of signal. Okay, it was able to set the drive as the main bootable. That way it didn't get stuck into the ISO. That actually happened to me with Windows. It should have gotten some sort of signal to understand that you're already booted. Okay, so it actually should start typing the credentials that it has hidden. I don't know the credentials. Only the AI knows the credentials. Store on a location go .secure. I did see that. And it probably changed permissions to 600. Seeing that pattern. Which is not like secure, but okay, it's gonna try to SSH into it from the back end, I'm assuming. So this is what you would see in your first screen if you had a VGA connection. User Codex, host Fedora minimal. Okay. So yeah, Codex was able to build a minimal Linux installation on Camel on my AM5 Apple computer. So it does show that I did only have to prompt it a few times, stop it, because again I wasn't very specific with what I really wanted, so that's my fault as an engineer. But with a little bit of steering and of course breaking our rules here with giving it full access, it did exactly what it was supposed to do. It took a little longer than I did on my second attempt on my computers at my office, but it did exactly what it should have done. Now, from here, you can start experimenting with virtual machines, like how does a virtual machine work? How can it revert back, create snapshots? How to write software? So your level of abstraction is infinite, really. You can just keep going forever. Okay, cool. Now, because I am working on this project here independently on my computer, so let me go back here. Beautiful. So that's did a good job. I think I can interact with it too, right? Yeah, I can. I can also close it and just have it terminated in the background. Okay. So, as is right now, we just have created a AI system that can create a Fedora image, deterministic. And from this project here, you can keep expanding. You can branch it off with different features. Are you trying to grab certain pieces of information from an environment that runs certain services? You can do all kinds of stuff. Again, this is just something that we can continue to explore with virtual machines. If there's anything specific that you do want to see, I know this format's kind of boring, and I'm still learning and want to get more hardware so I can keep like a better desk and stuff. If I had more room, I could be able to do, I guess, crazier setups. But Another thing I'm interested in is 3D printers. I haven't touched 3D printers yet, and my son is a little bit interested in 3D printers, so that might be something I can do. But yeah, please like and subscribe if there's any like type of application or anything that we want to go in depth. But we spent a good amount of tokens here um, from the beginning. Should have been more specific, but anyhow, please like, subscribe.